So next subject is you have to shift our mindset to a bit more of industrial thinking, or I would say more cloud and communication in the industry area. So the design thinking was a soft skill, but please remember that as part of this discussion, and I'll summarize that how this all come together. First thing is defining industrial Internet of Things, right? What is it? It's interconnected sensors. I think in the starting of the session you defined it. Thanks for that. But that's important aspect is you're interconnecting different devices, sensors, instruments, and another key word is called edge devices. That means devices which are sitting more close to where the users are using the tools, right? The end user location, if you can call it, right? So the edge devices which are being used to deliver that particular service, and how they are networked with each other in terms of how they are connected with each other is very key. And more importantly, how do they work even with, more importantly, the industrial applications which are already there, right? How do you really enhance the way the industrial applications are working? I think that's where the industrial IoT is moving towards, right? Now, why is it important? We all know automation, higher production growth using high-end data analysis, on which raw materials to use, how to use, when to use, and how automatically to select them. And once you use them, how do you fix the supply chain, right? Your assets get depleted very quickly as you build more automation around it. So how do you make the entire back-end supply chain connected with that, the whole asset life cycle of supply chain and the entire assembly line, you call it in industry. So automation is key. Even more important is now operation, because people are looking at hands-free supervision, remote monitoring, and things like that to have larger scale automation. Operations also have to be automated. There is I would say way more advanced analysis is now being done to look at predictive nature of data. So the more you connect all these devices and sensors, you need to track them constantly and try to see whether they are going to break down very quickly or not. If it's a human will say that he's sick, but the instruments don't say that, right? Not just about the battery life and things like that, but also other aspects will come into play with industry IoT, depending on the nature of where they're going to be used, especially in terms of robots and even AI-driven auto repair workflows are going to be coming up. So it's a very exciting area to be in today. I think there is a lot of room for growth here. There is a lot of room for digitalization, and it's going to evolve so much that there's going to be so much work to do for us in this area. But just that we have to change what we think as our previous generation of work to the next generation of work. I think that will define human being in the future, right? And efficient and cost-effective planning, right? Use of very modern immersive technologies to do planning, and one aspect will be design thinking as part of that also, right? So that's where the journey is. Just to for people who are new to this, many people would know this, but I'll very quickly run through the evolution journey of 4.0. 1.0 was basically using water and steam as your resource, I would say, right? But you built smaller, you moved from homes to factories, which was the biggest shift, and you learned how to mechanize production units, right? In 2.0, electricity became the biggest factor, right? Assembly lines started coming into play, and mass production became a norm, right? And that led to more computerized view of usage. That's what electronics and IT came into play with 3.0. That's where we are in the hybrid right now of 3.0 and 4.0. More importantly, automation is something which is very well understood now. It's not something which is, it's done at different levels, at hardware level, at software level, at even at people process level, right? So there is automation already in place. So 4.0 basically is an enhancement of 3.0. But trying to make it more autonomous. I think that's where it's going to get challenging, because automation is something we have not really fully achieved it. It's not easy to achieve it. We have done it in few places. It costs a lot of money and resources to do that. So it has been selectively done in some places. But the moment you decide you have to be autonomous, there is no choice. You have to be entirely automated, right? That's where you need external resources to help you with that, which is where the connection or with the other intelligence like AI and machine learning and data science become very important for us to work through. And what this will evolve is what I call as a smart self-thinking, right? Systems. That's when you would be able to achieve. If I can call this as a design principle of Industry 4.0, right? We want to achieve autonomous smart machines and devices. It needs to be a blend of physical and digital worlds. People have called it as a cyber physical system, which means a very blend of digital as well as physical system, which need to work hand in hand. So I just was lucky and fortunate enough to work with some partners in this area. I will share with you later. But that's where something I see that there's going to be a very interesting future of how this works. Now, the functionality wise is going to be self-optimized usage of resources and the whole assembly line resources, the self-configuration capabilities for it to create instances by as many instances of that assembly line that it needs, automatically configure it, reconfigure it by doing self-diagnosis. And very important term is cognition and intelligence support of workers. I think predictive analysis, all the cognitive aspect of it will come into play. And also the safety aspects for support of workers, all that's also going to be key in Industry 4.0, right? So that's where it differentiates from a common IoT. IoT is also connected systems and software and infrastructure with a network and so on. But where the industrial IoT comes into play, more importantly, is that you can really, it will result in a very high risk situations, right? Even a factory blowing it up, or life-threatening situations, depending on what the industry is all about, right? So it's about improving health, safety of people also, right? So that's where this cognitive aspect of it are going to be getting a lot more attention and investment also, right, from businesses before they just jump into automation. So that's a very important, again, a human-centric approach of how you look at industrial IoT, right? Not just as a tool and as a function. So how do we take care of that? It's a serious problem. So how do we take care of that? So one thing is going to solve the problem is connectivity has to be, I call it as a new oxygen. The world calls it new oxygen. That's need to be enhanced much better. It needs to be kind of an always on, but there are many options to do it. I've listed a few that I'm very aware of. In the near field area, you obviously have in the past a wired connection like copper and fiber, so that's definitely given, and that would still exist for a very long time as a plan B. So I don't think that will go away. But future investment might be more into the wireless aspects of it. So that's why I'm highlighting this. If it's people have tried near field communications. I'm just naming Bluetooth and Wi-Fi, not too much in the industrial area, but as a connectivity options, yes, they are there, depending on where you look at it. Then there are more proprietary tools also like Zigbee and Sigfox. They came up with a lot of proprietary way of doing it. And then the low range connectivity like LoRa, which is an open source network, open network you can call it, with open protocol called LoRaWAN. They came up now, and then eventually the narrowband IoT came up, largely extension of your GSM network or the mobile world, and they are effectively used because they also leverage on the SIM cards and so on, and the LTE or the 4G is slowly shifting to the 5G mode as and when the decisions of security and ultra reliability are coming in. So if it's a low cost coverage aspects, power consumptions, right? For example, LoRa can give you battery life from years to days. One particular device can last for 10 years, right? So there are reasons in which many of these have been selected or not selected, right? And that's when it's evolving. So I just thought I'll give you some. Let me go through this definition, and then I can go through a video of LoRa to just give an example of where it stands. Sigfox and LoRa largely very similar. LoRa uses radio waves from the unlicensed band, like your very short wave kind of a model. So it's free, rather free, not so expensive. LoRaWAN uses open protocol. Sigfox uses a proprietary. I think that's the only difference. Apart from that, not too different from the nature in which they're working. They provide more than 10-kilometer range between gateway and devices in the rural areas, 3 to 5 kilometers in urban areas, because of buildings and other inferences that you get for the radio signals transmission, right? But LoRaWAN as a protocol is good for running an isolated or private network on a farm or in a city or in a remote place. It's very ideal for sensors that can occasionally need to send a value, right? For example, soil moisture, right? Sensors. So if you're in an agricultural area or very far off industrial area, you just want to have a heartbeat, not too much activity, then you can just leave it there with the gateway, and then it connects to you with a very low power usage, so you don't have to send people often for maintenance purposes. So that, and lesser you measure, I think the recharging capability is also improved. So very effective way of using, or even a water trough sending a notification when it's empty, things like that, right? It's such a good system for tracking and monitoring wildlife in predefined area. People have done that in Africa and South Africa with wildlife. There are very interesting cases there. So let me just quickly jump into one video on or two videos on how LoRa has been used by one of my partners that I've evaluated in the past few months on how they've used. I'll remove my headset so that speaker.
Over 25 billion objects are expected to be connected to the internet by the year 2020, creating the Internet of Things. These applications will transform our daily lives and business activity in many ways. So you can think of smart metering, object tracking, applications in precision agriculture, and many others. However, today's communication systems are not built to support this coming wave of connected devices. Traditional systems are too expensive and too power hungry for broad deployment. The smart devices of the future need a new kind of network.
We have developed a cloud-based radio communication platform optimized for the Internet of Things. Using our solution, customers can connect devices to gateways from more than 5 kilometers away, and they can often run on a single AA battery for more than 10 years. We provide our customers with a complete software solution to operate, manage, and optimize large-scale, low-power, wide-area networks for connected devices.
Our customers include telecom companies, utilities, and just about any company that wants to have their own Internet of Things network, creating an addressable market of over $2 billion yearly for Orbitwise. To join Orbitwise and enter the Internet of Things revolution with us.
So the interesting thing I wanted you to notice is there is a use of software-defined networking they use. For example, a lot of the data that these edge devices collect, they get eventually stored and processed in the cloud, right? So you have multiple ways in which the data can be streamed so that it doesn't lose anywhere. You don't lose the data from anywhere. Wherever this gateway is available, it starts sending out the data stream. And then it gets collected in one particular server. That can be in a cloud, it can be in a private installation, depending on how you intend to do it in the future. But more importantly, they also they have created this concept of processing it in a network server rather than processing at the device. I think that's a very subtle difference in which this IoT is bringing about the need for what I call as an edge processing capability, right? So we will go through more again in the architecture, but that gives you kind of an idea on how IoT is evolving, and there's no reason why it can't be used in some industrial aspects. One more interesting thing was also in a noise video. Unfortunately, this is in this is not in English, but you do have an English subtitle to it. But effectively, let me just go through with you, is that in Switzerland, in Geneva, they created these, they installed these devices in these, if you can call it, these pipes all across the city, and they are basically used to track the noise level, right? In the traditional model, what you would do is you will have huge devices coming and checking here and there. but this is something which is a low-cost solution where you can just install it in any place like this, and then it just keeps sending you the feeds now and then. So since it's a low-cost option, and you can keep distributing and processing it somewhere else, you are allowed to analyze it over a period of time. You can analyze it on different times of the day at different situations, and you can create different metrics around how you basically do it. So it changes the way in which devices are being used, and the impact that it brings to the society, right? So I just wanted to share that. That video unfortunately is not in English with subtitle though, but I can put it in my YouTube, and then I can share it, and you can have a look at it later if you want a detailed view of it, right? So going back to the slide, so let me go back to the headphone, so you can hear me really well again. So that's where I think Sigfox and LoRa kind of solutions have come into play. So the next connected option was NB-IoT, right? This is again runs in the mobile telephone radio spectrum, but largely not so expensive because they used compared to LoRa and others, not so expensive, but still inexpensive because they use the mobile network and technology. So you have the cost along with it. But it used unused channels or free space between the LTE channels that you and me use to download videos, and Facebook and Google and WhatsApp and so on. So it uses a different channel. But it's a dedicated regional frequency or channel has been created by the telecom operators, or the resellers of them, or virtual operators, if you can also call it. It's ideal because it uses a GSM technology, and then it's easy to enhance with the future mobile technologies that come with it, right? And more importantly, I think fleet management has been a great use case for it, because you need to, even in the industries, when you move around objects in a very faster way, you can't lose connectivity, and then fleet management becomes an important use case for such using such technologies, right? So the good part of it being a cellular oriented technology, you don't really lose. I mean, you have a more reliable, I would say, connectivity than others, right? In the previous cases, it's not very data heavy. It's just sending signals and metrics, and you'll have to they call it as a chirp mechanism, CSS, chirp spectrum. So it keeps sending short messages. But here it's a regular GSM metric. So huge amount of data can be sent across, and more processing can be done. But that's where I think the evolution has moved towards what I call in the industry as a private LTE or 5G, right? Currently, private LTE is available where you create your own network. You don't want it to be confused or interrupted by any of the public network that the telecom companies are using. So you want a very private setup. I would say at least a logical setup, if not a physical setup. Just to be clear, physical setup will be very costly. Moving forward, it will become easier and easier. There are companies who are doing it, but at this point of time, it will be a logical private network. And 5G is being looked at purely from security and dedicated latency reasons, right? Especially in the industrial regions, manufacturing, shipping, etc. So just to give some 5G functions which are important to understand before we go to the architecture is there is a world functionality called enhanced mobile broadband, right? Which serves very highly dense populated metro centers like us, like Bangalore, Singapore, and our metro cities and so on, right? With huge downlink speeds up to 1 gigabits. That's the future. Depending on the band that you use, you will get it. And at the outdoor, at least 300 megabits per second, right? Basically, 5G is defined by the millimeter wave, wave, right? And the capability of the antennas to reach the frequency band. And the second functionality is ultra reliable and low latency communication, in short called as URLLC. This is where I think the industry will really depend on 5G for very high mission critical, business critical communication needs, right? Where it's not about bandwidth that we talk about, it's more about the speed and the reliability, right? Where latency should reach as low as 1 milliseconds. Of course, it's not there yet. Why I'm saying that? Because right now, I think, or right now, till 2019, the early deployment was 30 milliseconds. But there is also possibility to reduce it with some edge server components, and that's where the edge capabilities come into play. There's also a term here in the edge that you need to understand, that there is an evolution which has happened here in terms of edge servers, which I'll cover with this word here, which I've introduced in the next definition, called software-defined networking, virtualization, and cloud capability. What has happened in the industry is there is a slow movement away from a very hardware-centric solution to a mixture of hardware and software. You, of course, need hardware, but you also take out components which were logically built into the hardware into software components, and we call them as the network functions, right, or software functions. For example, you don't need in a very crude example, you have a Wi-Fi router at home, but the router is just a box with just some signal. But you can definitely add more intelligence to routing and firewall and things like other capabilities onto it using a software processes. So that's what has evolved, and that's what is making the edge servers more and more feasible to implement and adopt. And you can have a complete network much closer, or a server network much closer to the edge devices or the end user devices, and you can have a share of the load of processing from the end user device onto the edge devices. I think that's where you can also help in the latency aspect of it, right? So this is going to be very key in jointly working between cloud, 5G, the connectivity, and the industrial companies, right? And there is a consortium actually working towards that. I can share that consortium later. I think it's called 5G ACIA, or even IIoT is helping with that. So there is this dedicated industry bodies which are working towards that. And what the telcos are trying to do is that once you are able to softwareize, or I would say, convert some of these network function as softwares, right? Once you make it software defined, you're able to create a very dedicated compartment of the network for a particular company or a particular industry site or a particular set of industrial sites and things like that. So we call that as a network slice, right? A dedicated slice for that enterprise. So that's now being possible to create a private virtualized network on top of the 5G great speed connectivity. So it's not just about 5G in the connection. Along with that connection, these are the components which are actually helping the 5G to be leveraged very well, right? You can leverage it better. So some usage scenarios across these three functionalities. Massive machine is around huge set of communication like smart city programs and so on. IMT is another standards formed by IIoT for international mobile telecommunications. So they have defined this. Self-driving car, I don't really call it as a car with connectivity, because I think it needs to work without GPS, without connection by itself, right? If something goes wrong, so it needs to work differently, but it will definitely constantly connect back with a URLLC for other critical functions like accidents and insurance and things like that, right? So that will be a different reason. But more and more mission critical industrial automation and augmented reality come into play on the right hand side. URLLC will become key, and more data centric, like what you and me use of downloads and upload speeds and 3D videos and smart consumer applications. Then enhanced mobile broadband will come into play, right? So I think that's where you will see the evolution happening in 5G. More and more the spectrums open up. That you would see that. Now, yes, we're talking about this. Have we missed anything important? Yes, there is the still aspect of data usage, the storage, analysis, and how you action them, right? So very quickly going into the architectural aspects of it. To solve the Industry 4.0 design principles, if you remember, we talked about optimization, configuration, diagnosis, and all done by itself, right? Self-care and self-cognition into the support, right? We need to architect two aspects: the connectivity, which we saw, the different aspects of connectivity, and the AI-enabled edge infrastructure. So the both aspects have to be considered. The connectivity has to be an always-on infrastructure, for especially for industries with a private network. That's why the emphasis was more on the private network on my side, and hybrid options for the resiliency factor, right? So that you have always-on connectivity to support you with that. Remote planning, management, and operations. You have a huge data movement from the edge device to the operation center. The edge device has to be much more, if you want to enable remote planning and more intelligent self-diagnosis analysis, you need to collect the data, process it in the edge, and then you have AI-driven application that will feed back and also do the self-diagnosis and self-correction if required, right? So that's kind of an automation that need to happen. So for that, how do you build architecture? You can build everything on 5G. There is nothing wrong, but I'm just giving an example of a hybrid. So if you go with a LoRa in places where you can't really access, for example, someone was building one of the Obiwise case study was proof of concept that they did was in a height inside a mountain. There was a tunnel and a cave, right, where they built. They put sensors and they had connectivity through gateways and network servers. So you don't get connectivity that easily there. So you install a small network setup through LoRa. So for not so accessible sites, you connect that to the gateways and eventually to the network server of LoRaWAN. And on an NB-IoT 5G industrial situation, just one high example I've taken here as robotics, but it could be a combination of NB-IoT or just 5G. But you also have maybe sensors there or programs there or edge devices there, which will start sending you through the RAN, physical RAN, or the virtual RAN, which is becoming more and more popular in the market for building cost efficient and vendor independent network. That's coming into play. So I just call it as a virtual RAN or an open RAN. You can search for both on the internet, you'll get that. And the edge compute, right, which has all the AI-driven programs to act on it. But more importantly, there you also need a wired fiber connectivity for redundancy, for mission critical. That's again given. You can't really avoid that as much as possible, right? And then you collect back to the access of the telecom network, where you have a slice of the network which moves on to the aggregation network we call as a backhaul, and then the mid-haul, or technically just a backhaul, to the core network, and eventually leads on to your corporate data center for further analysis and management, right? So you could do that at the edge, at the access, or you could do at the your data center wherever it's sitting. So this is how the architecture will more and more evolve, I would say. Then the last aspect is how is design experience changing the industrial or maybe even the healthcare world, right? So I'm going to introduce one more word here or terminology here. You might have heard as a digital twin. It's a digital replica of a living or a non-living physical entity, which means it can be even a process or a person. It refers to asset, process, people, place, systems, etc. But more importantly, it helps you simulate a physical entity, right? So where you can't really access, for example, inside containers, inside shipping, right? You can't really go and keep accessing those information or those locations very easily, or even submarines, right? So how do you really have, we are working on some case studies where we are sending, we are trying to analyze how to collect data from those areas where you don't have, even satellite connection remotely now and then in the ships, right? So how do you do that? So those kind of accessible areas, you actually build a digital twin for them. And that will help the designers and architects to plan, innovate, and solve a problem by simulating some real world situations or operational issues and conditions. So that's where I think the predictive aspects will come into play. We call it as, if it's applied in predictive analysis, it's called as predictive twins, by the way. So this RISE is actually let me run an example of the company that I've been solutioning and working, which you call as a total image. It'll give you an understanding of how it's going to be used in the industry. First is just a quick example.
Automated inspection. The process is simple. This is a 360-degree video captured manually by a staff member or with an autonomous drone. It is analyzed by our AI algorithms to detect issues automatically. The detected defects are automatically located in the 360-degree video. The inspector can review them from his office, doesn't need to go on site any longer. The inspector can also add specific information. If on the video he sees specific issues, he's going to say that this cut the tree branches. He could add any content linked to this, further images, videos, documents. For the time being, we are just going to put an icon like this. All stakeholders who are alerted and given rights to access this inspection report can visualize the issues and their situation directly in the images. Hence, it's easy for contractors to prepare and manage the remediation work without going on site. This example is to show a simple automated inspection process from only one 360-degree video, generating the corresponding inspection report. With a key result, people can collaborate remotely, understanding each other and understanding the issue even when the situation is complex. For large estates and big organizations, it is interesting to create a multi-sources feed to the inspection report. On top of the autonomous 360-degree video captures, like the example before, any picture or video captured manually by a staff with their smartphone will be analyzed by our algorithms, as well as the real-time feeds of fixed surveillance cameras for illegal parking, for example. All detected issues are located in the same referential that we call the estate walkthrough. Hence, the inspector can review and publish a full inspection report for the whole estate. For example, everything that has been detected automatically, like here, there is a detected leak here on this pipe. We could go also to real-time live camera and actually get access to real-time data. Data could be also from sensors. In the same way, somebody could actually get access directly to a sensor and to the analysis of a certain machine. This is why it is interesting to build a walkthrough from 360-degree videos of the whole estate, including both indoor and outdoor situations, knowing that it takes 20 times less time to capture videos than scan lasers, is way less expensive to capture and maintain, that true live images are immediately understood by anyone. Videos can be linked to maps. People could teleport directly to specific situations, to specific sensors. The value proposition of Total Image for facility managers goes beyond the inspection process. It is a cost-effective solution, allowing staff and external personnel to understand, prepare, and manage operations in the estate. The walkthrough hosted in JTC Cloud becomes the extended workplace where employees are able to work and collaborate remotely in the images of their facilities, linked to all enterprise data and workflow applications in their information system. Companies save 50% of the time between the issue detection to the final fix.
Okay, so so back to the so I hope it gave an understanding, but some of the key things that you want to look at, right? We started building this solution or evaluating this tool for a construction management company and also shipping companies, right? Where we started looking at few aspects. One was not everything needs to be, the immersive technology doesn't have to be too costly. So we looked at a very cost-effective option of doing that. You can obviously do it with AR, VR, and if you need to go more and more real time, I think that would definitely help. But at this point of time, it was more for operational analysis and design aspect of it. So engineers or designers can use that particular section like a digital twin of that particular container or that particular industry location, and they can analyze how difficult it is to access certain places, how difficult it is to change certain or work on particular aspects of operations. So they understand from a human-centric point of view how to execute the task will become difficult and how to change it accordingly or redesign it accordingly, right? We also used image video feed analysis to process that couple of feeds and try to find out the leak. For example, there was a place where it talked digitally. Inside the video, they had recorded there is a leak in that particular place, right? So iSnap is one of the AI engines which was used to take from total image the image or the video and then analyze and compare with what has been changed from the past to now, and then highlight if there is any leak or any other corrosions or any other disturbances from the previous photographs or images. So that kind of an analysis was being done. And this particular area where we're going is obviously called as a computer vision, is a field of AI to train the computers, right, to interpret and understand the visual world, right, using digital images and then using deep learning models and allowing them to identify objects and classify them as good or bad or whatever, right? So you can allow them to classify it. So that's where the computer vision is moving towards. And for all this thing, you need really, you really need a edge cloud network, right? That's what I think I was leading to. Because in real-time situations, you saw there was a real-time feed, like inside a shop, like a security camera, but there was a lag. And if you want to zoom and find out more about the information, I mean, that was a simple video. It was just trying to tell you the number of visitors, right? But not anything about the visitors. But if you want to do something more in depth about that particular security camera, then you need more access to it, more sensor information to be handled, right? That's where 5G and connectivity becomes important. And industries also require, we already talked about network slicing, but that's where I think the edge computing will come into play, because you have heavy content management and processing that needs to be done to execute that. So to summarize all of this, I think I close it as a creativity, connectivity, and a cloud discussion for industries. You definitely use design thinking as per my previous set of slides to innovate based on really human-centric requirements or people needs. Use secured connectivity options as per the needs and the cost. You have multiple options. You can have hybrid based on the locations, and you don't have to go with one for everything. Also leverage cloud resources. It can be private cloud, doesn't have to be a public cloud. So there is a lot of difference between the two. And also edge compute resources to balance cost, latency, scalability, and resiliency, right? So you need to consider all these things and build that. Use digital twin technologies to do the prototype. I think that's where digital twin I brought back to understand that design thinking prototypes can be done using digital twin technologies. There is more room for technology growth in that. It's an evolving area, but I think more and more in the future, that's where I think it will lead to. So at least some tools we saw today are enabling that, but there'll be a lot more coming in immersive technology moving forward. There's a lot of innovation happening there. And then obviously use the design thinking to validate and understand the viability of whatever you're building or trying to innovate and create. So I'll stop at that for any Q&A and feedback or anything that you want to know more.
Okay, I wish to thank Mr. Anand Venkat for his inspiring talk. He started from the definition of design thinking, telling that it was a soft skill, which I was not aware of it. He explained with good examples. He gave a full-fledged example of the tools or the templates, as he quote, used for the process development taking good example like healthcare applications. Then he gave a good insight of the industrial IoT growth in the industrial IoT as such, taking examples and also showing videos about it. Okay, thank you very much, Anand.
Thank you all
And
for your
Anil
time.
also.
Thank you all for your time.
Thank you. Thank you.
Thank you. I've given my email ID if anyone has other questions or ideas or joint research that you want to do in the future in these areas and subjects. Feel free to connect with us and we can do something around it. Yeah. Thank you. All the best to you all and stay safe. Bye.